Okay. So uh, let's move our concentration towards feedback principle. Okay. And after this semiconductor, we will again study some semiconductor devices in later part. Okay. We have op-amp, then other solid state devices, different diodes, okay, then optoelectronic devices. So we will discuss it later. Okay. So now let's start discussion on feedback. I guess all of you have at least some idea about feedback, and feedback is always exist not only in circuits but in every spheres of life. Whenever you do something, you want some feedback, that is some discussion about your output resultant. So feedback is nothing but if you have some discussion or something related to your output, this is your feedback in general. But in electronics, normally feedback is related with amplifier. Feedback is related with amplifier, and since it's related with amplifier, therefore, of course, there should be some basic amplifier and some relation with output of the amplifier and then input of the amplifier. Okay. So in electronics, mainly feedback amplifier is a system of network in which a part of the basic amplification system is returned back to the input and mixed with the external input signal suitably in a desired manner. This is your feedback network. Okay. And simply a feedback network, it's a network of several elements in electronic circuits, and it consists of 1, 2, 3, mainly 4 parts. One is your basic amplifier. Okay, this is important because without basic amplifier, you cannot design a feedback amplifier. You have to have a basic amplifier. Then you will play with the output of the amplifier and input of the amplifier. Then you will say that this is your feedback amplifier. Okay. So at the output of the basic amplifier, you are having a network. This is known as sampling network. Okay. Sampling network is a network which will sample out or choose or select a portion of the output in a desired way. Okay. For what? To send it to the input. To send it to the input. Okay. And this feedback network, this is again related with this one. Sampling network is to sample out a part of the output, and this will mainly play or work with this sampled signal to maintain desired phase or amplitude of this chosen signal. Then it will send it to the input. And here you will have another network. This is called mixer network. The function of this network is to mix the external input and this signal fed back from the output to the input in a suitable manner, so that this mixed signal can go to the input of the basic amplifier and amplification occurs. Okay. So this is your simplest feedback network or feedback amplifier. Okay. And this is the final output and this is the initial input. Okay. So this is your feedback network. We have 4 different networks: sampling network, then feedback network, then mixture. Okay. Now, depending on the phase of the sampled signal or signal fed back from output to the input, we have 2 types of feedback. One is positive feedback. here the feedback entity mixed with the external signal is in the same phase, and another is negative feedback, where okay. So depending on the sampled signal phase, we have two type of feedback. If the phase of the sampled signal, that is signal fed back from output to input, and the external input is in same phase, we say it positive feedback. If this is in opposite phase, then we say it negative feedback. Okay. Now we draw the earlier network in a another way, just with say schematically. Okay, so this is your basic amplifier, gain with A. Since it's an amplifier, we have a gain. So let us consider A. This is your feedback network, and this is your sample network. This is your mixture. Okay. So let us consider Xi. Xi be the external input signal. This Xi. Okay. No confusion. Then X0 is the output of the feedback amplifier. Okay. Main amplifier. XF. XF is the feedback entity. Feedback entity means the signal fed back from output to input. Okay. Xi dash is equal to sum of input signal and feedback entity. That is input with feedback. Okay. So this is input without feedback, external. So eটার সঙ্গে feedback add হওয়ার পরে we have Xi dash. So Xi dash can be written as Xi plus minus XF. Plus for positive feedback, same phase, minus for negative feedback. Beta is known as feedback ratio or feedback fraction, and is defined as fraction of output signal fed back to the input. That is XF divided by X0. Beta is equal to XF divided by X0, and it mainly characterizes the amount of feedback, and this is known as feedback ratio, fraction of output fed back. কত ভাগের কত ভাগ? Okay. A is the gain of the basic amplifier, that is gain without feedback. A is the gain without feedback. মানে this amplifier, whatever it gets at the input, it will amplify. Okay, so this is the gain of the basic amplifier, and this is equal to output divided by input. So etar input হচ্ছে Xi dash, and AF is the gain of the whole system with feedback. So in that case, original output divided by original, your external input. So X0 divided by Xi. So this is equal to voltage gain with feedback. And remember, this gain includes the effect of feedback, because Xi actually changes due to this part for this one. That's why this is different. AF is different from A. Okay. So dividing equation 1, this one, by X0, we can write this one. Then simply by putting this A and then 1 by AF is equal to plus minus beta, we can do some simple mathematics and can have AF is equal to A divided by 1 minus plus beta. Okay. Initially we started with plus minus beta. So that means for plus we have minus. Positive feedback, AF is equal to A divided by 1 minus A beta. That is gain increases. And from this we can say that AF greater than A. Or here we can say that AF less than A. Okay. So we see that in case of positive feedback, gain increases, but in case of negative feedback, gain decreases. Okay. So in our syllabus or topic, mainly we are interested that even if the gain of the amplifier decreases in case of negative feedback, then why negative feedback is important. So this is the main topic of our discussion. Okay. Now, depending on the connection of this part, this is your sampling network and mixer network. We have mainly 4 type of feedback system or topology. One is voltage amplifier with voltage series feedback. One is current amplifier with current shunt feedback. Okay. So this is, you see, in input is in series, output is in parallel. Here, this input part is parallel and this part is series. Okay. Then transconductance amplifier with current series feedback. Here, current is in series. Trans resistance amplifier with voltage shunt feedback. Okay. So this is in parallel shunt. Okay. So we will discuss this 4 things little bit more. Okay. So now, before going to check the effect of feedback, first let us see how this voltage amplifier looks like. Okay. So in case of a voltage amplifier, remember here no feedback is there. Only we are talking about a voltage amplifier. Okay. So for a voltage amplifier, mainly output voltage V0 is proportional to input voltage. You can see here output voltage, input voltage. So output is proportional to input. We can write V0 is equal to AV VI, where AB is the gain of the amplifier. Okay. Now we will write Thevenin's equivalent circuit for a 2-port network. Thevenin's equivalent, actually it's a network theorem. Today I have shared one PDF in WhatsApp group, so you can go through. Using Thevenin's theorem, if you have a very complex circuitry with, say, several voltage source, several resistance, then what you can do, you can simply replace this circuit by a single voltage source and a resistance in series, and say this is your load, RS, say VS. Okay, where this is the or you can write RVT, Thevenin's equivalence. Okay, you can whatever maybe. So say if you have a circuit like this, V1, then say resistance, here again resistance, here again resistance, like this. So we can write this circuit, say several resistance, you can see RL, we can write. Okay. So how we'll do it? How we'll do it? So main issue is, whatever complicated your circuit, if it is a voltage source, voltage control circuit, you can replace it with a voltage and resistance in series, where voltage is the equivalent, Thevenin's equivalent voltage, or resistance is the equivalent resistance with load. Okay, load mainly to have the output. Okay, so how you will do it? So normally, while calculating the equivalent resistance, what you have to do, you have to consider this. You have to replace this voltage, all the voltage. Here I have shown only one voltage source. You can have more than one voltage source also, no problem. So all the voltage source by their internal resistance. Say for the sake of calculation, say internal resistance is nil, or you can put a resistance here, no problem. So if you omit it, then, and if you look from the outside, from the output side, okay, then in absence of RL, the equivalent that is from here, equivalent resistance. Equivalent means here you can see, you can write this plus this parallel to this, say R1, R2, R3. তার মানে এখানে RTH, right here, RTH is equal to, say, R1 plus R2 parallel R3. Okay, this is your Thevenin's resistance. So this is this. Okay, and this is the equivalent potential. So to calculate this, the equivalent potential koto, this V, what you have to do, you have to say just calculate this voltage. You see voltage drop across this one and this one same. So this is equivalent here, same. Okay, but if you have, say, in series or other places, then voltage drop you can calculate using your potential divider circuit. Okay, potential divider circuit. Simple, say, if two resistance in parallel, then voltage is same. Series hole R1 R2 divided by R1 plus R2 into R1 R2 divided by R1 plus R2 into VS. Okay, so this is your equivalent resistance. Equivalence potential. So here, for this simplicity of the analysis, what we will do, we will replace the voltage amplifier or represent the voltage, express the voltage amplifier using simply Thevenin's theorem. What we will do in that case, say it's a very complex amplifier with so many voltage source, so many resistance, but what we will do, we will replace all the resistance with an equivalent resistance RS and all the source with an equivalent source VS. Okay, so this is simply we replace this. Okay, now another issue, whenever you are dealing with any electronic circuit, you will give some input, say external, say here, say you are giving external Xi, but due to presence of several component of the circuits, this amplifier may get an input which is different than this. Okay, so for example here, due to presence of feedback and other issues, you will have the input, although you are giving Xi, but this amplifier will get input Xi dash. So due to the circuit parameters, we can say that at input part of this amplifier, a change in signal occurred. On the other hand, we can say that we can say or represent this change as the presence of some kind of resistance in the input part, so that the input signal changes. This is known as internal resistance. Actually, practically, physically this is not present, but practically its impact is present. You got my point? Here Xi and Xi dash is different, but no resistance directly is present, but due to other components this is different. Okay, so this one can say that due to internal resistance, the external signal changes little bit exactly to reach up to the amplifier. Similarly, you can see output here, just output of this basic amplifier here. but main output of the circuit here. So due to the presence of different components here, what we can have this, say this is your x0 dash. X0 dash may not be equal to x0. Why? Due to presence of different circuit component may not be equal to x0. Okay, but in principle, for an ideal case, it is expected that x0 should be equal to x0 dash. Then it's better. Similarly, here also, whatever you are giving for an amplifier, it is expected that the amplifier will amplifies everything. That means internal resistance should be very low. Okay, so a very good circuit, internal resistance, this is I am discussing with respect to voltage amplifier. Okay, so normally say that internal resistance কম বেশি চিন্তা করার দরকার নাই. Issue is that কি আমার whatever signal we are giving from external input, exactly this amount should reach to your basic amplifier. Similarly here, whatever output you are having from the basic amplifier, same output should go to the output. This is the ideal case for any kind of amplifier, whether it is voltage amplifier, current amplifier, transconductance, transresistance. Okay, so this will be related with voltage. This কিন্তু এই যে সেম সিগন্যাল এখানে যাবে কিনা, এই সেম সিগন্যাল you will get, whether you will get in output or not, this will depend on input resistance and output resistance. Okay, so now we will see যে for an voltage amplifier, whatever be the nature of the input resistance or output resistance, so that we can exactly amplify the external input signal, and at the output also we can have exactly the output. Okay, for an ideal case. So here you see for the input part of the voltage amplifier, we replaced like this as equivalent, Thevenin's equivalent, just an external voltage source, then resistance. Okay, these are equivalent, and then we assume, this is actually assumed, a resistance Ri. This is internal resistance, input resistance. Okay, that due to this we say that this Bs may have some kind of change at the exact input of the amplifier. Kintu we expected that Vs our exact input should be same. Okay, so now say we do some say analysis. From this circuit we can write Vi মানে voltage drop across Ri. Okay, so this is according to potential divider circuit. If resistance in series connected with the source, then potential drop changes. In case of current, if it is in series, current remains same. Current changes if it is in parallel, voltage remains same if it is in parallel. Okay, so according to potential divider circuit, if there is this thing, then voltage drop across Ri may be written as Ri divided by Ri plus Rs into Vs. Okay, now in the absence of load, that is if your circuit is open, there is no change in the output, whatever your amplifier is amplifying, you are having as output. In that case you can write V0 is equal to AVI. This is because AV is your gain of the amplifier and Vi is the input the amplifier is getting. Whatever the input Vs is, this amplifier is getting Vi. Okay, so in that case V0 is equal to AV Vi. Now Vi can be replaced by like this. So rearranging we can write like this. Okay, the V0 is equal to AV Vs 1 divided by 1 plus Rs Ri. So from this expression we see that if Ri tends to infinity, then V0 is equal to AV Vs. Okay, so Vs was actually our external output. So if Ri tends to infinity, then we can say that whatever we are giving at the input, our amplifier will get the exact thing in the input. So for an ideal case of system, for a voltage amplifier, the input system should have very high input resistance. Okay, So this is one point. Similarly, let us discuss for the outside part. Similarly, in the outside part, say V0 is the output of the amplifier, just output of the amplifier. But due to, your amplifier will have other components also. So we replace this with the equivalent system, say V0, then R0 in series using Thevenin's theorem. This is your load across which you are measuring your output with your voltmeter. Say the drop is V0 dash. So this is your exact output. So in ideal case, these two should be same. Whatever your amplifier is amplifying, we should have in the output. So V0 dash can be written as, again, using potential divider, the key drop across RL. So drop across RL can be written as RL divided by RL plus R0 into V0. Now, see, if R0 is 0, then you can see V0 dash is equal to V. So for a very good or ideal voltage amplifier system, it is expected that the output impedance should be very low as possible. 0 hole to kotai nahi. So this is the case for an voltage amplifier. Okay. Now say a current amplifier. Why we are discussing this? Because now we know that for an voltage amplifier to have very good amplification, input impedance should be very low, and input impedance should be very high, and output impedance should be very low. Then at the later part, we will see if we apply negative resistance, then what will happen? How this resistance input and output changes, whether it improve the performance or not. We will see it later. Okay. Now current amplifier, in an ideal current amplifier, we have output current proportional to input current. Very simple. Then this is AI is equal to gain. Now in case of current control circuit, we can again draw an equivalent circuit using another theorem. This is known as Norton's theorem. Okay. Norton's theorem said that whatever complicated your circuit is, if you have one or more current source and several resistance, then you can replace with an equivalent current source and an equivalent resistance in parallel. This is your Norton's theorem. So please go through the sheet I have shared with you. Okay. So this is your Norton's theorem. So since it's a current control device, so we have drawn the input part using Norton's theorem here. You see this IS is equivalence current and RS is the equivalent resistance. Okay. Again, we assume a resistance Ri, and this may affect the change in IS. But we want the key IS should be II, same. So that exact output should be amplified. Okay. Now say here again using this current distribution system, we have calculated the current II current. You see this RS and RI is parallel with respect to this one. So one part of the current will go this way, another part will this way. So this part, this amplifier will get as input. So we want to know how this. So II is equal to RS divided by RS plus RI into IS. So this is the actual input, although you are giving this, supplying this amount. Okay. Now from this expression, we see that if Ri tends to 0, then II almost equal to IS external, and that means all the external signal the circuits or amplifier gets is at its input, and it's amplified accordingly. So for a very good current amplifier, your input resistance should be very low. Okay. Now say what about the output? Again, we drawn the output using Norton's theorem, a current source and a resistance parallel. Okay. This is the output, RL mainly to have the output. Okay. So let's see how this RL looks like. RL means current through the RL. So IL is equal to R0 divided by R0 plus RL into I0. Okay. So this is equal to this, just reorientation. From this expression, we see that if R0 tends to infinity, R0 tends to infinity, IL equal to I0. Okay, that means whatever your amplifier is amplifying based on its inputs, exact amount you will have through the RL. So for an ideal case, for current amplifier, we should have output resistance very high. So for voltage amplifier, Ri should be, for a voltage amplifier, Ri should be very high, infinity. You can see here, this one, Ri. Then R0 should be very low. Here, opposite. Ri should be very low. R0 should be very high. Now say transconductance amplifier. In an transconductance amplifier, output current is proportional to input voltage. And Gm is a proportionality constant. We say it's transconductance of the amplifier. Okay. So now what we will do, since in the input part we have current, so input part we will use, input part we have voltage. So in input part we will use Thevenin's theorem, voltage and resistance in series. Okay, and then we will analyze. And if we analyze, we will see that Ri should be infinity. Okay. Similarly, here output, since current, so we will use Norton's theorem, very similar to the current amplifier. So we will see that output should be infinity. So both input and output should be infinity here. Similarly, for trans resistance amplifier, for a trans resistance amplifier, output voltage is proportional to input current, and here output voltage is equal to, this is proportionality constant known as trans resistance. Here output is voltage, so at output we will apply Thevenin theorem, resistance and voltage in series. Our input is current, so we will apply Norton's theorem and draw using a source and resistance in parallel. And here we see that Ri tends to 0, okay, and R0 also should be 0. So for this 4 type of amplifier, we can say that to have very good amplification, your voltage amplifier should be, for voltage amplifier, input voltage, input resistance, Ri should be infinity. Similarly, output resistance should be 0. Then exactly whatever you are supplying, amplifier will amplify, and whatever amplified you will have in the output. Similarly, for same thing, in case of current amplifier, your input resistance should be 0, output resistance should be infinity. Transconductance amplifier, your input resistance is very high, infinity, here also very high. Trans resistance, both input and output resistance should be 0. Okay. So this is the ideal case, but in practice it is not like that. Never it will be 0, never it will be infinity. So we will see, now we will apply feedback to all these 4 signals, negative feedback, and see how this Ri changes. Now, if we say apply negative feedback here, that is voltage amplifier with negative feedback, and if say RIF, meaning input impedance in presence of feedback, if this is greater than Ri, then we say that the performance of the amplifier increases due to negative feedback. If say ROF, meaning output resistance impedance for voltage amplifier in presence of feedback is less than RO, then we say that this is an improvement due to feedback. Similarly, say here, if you apply feedback and if you see that both RF, RIF less than RI and ROF less than RO, then you can say that this is again an improvement. Okay. So in today I shall stop here. From next class we will apply feedback to all these four amplifier, and then we will check how this input impedance changes due to effect of negative feedback. Okay, whether it is good, that is improve the performance of the circuits or not. Okay, so thank you very much for today. If you have any query, you can ask me. So if no query, then please go through the notes or books, and then if you do not understand any, if you feel any confusion, then you can ask me. Okay, so we will meet next Tuesday. Okay, and next Tuesday I will finish this topic also. So Wednesday I will go for a small exam. Okay, so this is a notice for you that you please do prepare well both the topic I am teaching till next Tuesday, because Wednesday we will have a small exam. So any issue? Juipal, do you like to say something? Juipal, are you here? Anupam?
Yes, sir.
So any issue, any suggestions, any query?
No, sir.
Okay, so next Wednesday we will go for a small exam. Okay?
Sir, can I say something? Sir, can I say
Yes.
something?
Yes, yes.
Sir, it is all about our regarding exam. Is the marks of our upcoming exam, that is Wednesday exam, will be added in our mark sheet?
So my question, again, the answer of your question is another question. My question, if there it is not added, so you will not, I guess, read, and I guess you will not appear the exam. Is it so like that?
No, sir. Actually, sir, beside this, sir, Ratan sir have told us that class test. He will take us every week one class test, and that will not added the marks of this exam will not added our mark sheet. So, sir, hence, sir, I have told you that it is our internal exam or like class test. So, sir, yes.
You see, whenever someone is teaching, he will always ask question. Okay, so question may be in written form, maybe in Viva, whatever may be. Okay, so maybe internal is based on this. You never know. Thing is that internal is there, 30% is from internal. So it is not necessarily that internal is based on only one exam. Maybe it's a series of exam. Okay, it's an internal assessment. So it's not like that yes, I will take an exam for internal. It's not like that. There may not be any routine also. This is one part. Another part, now pandemic is going on. Even HS also there was no exam. Okay, so how they do it? Based on some earlier interactions, maybe pre-test, maybe class test. So many issues are there. Okay, so every exam, every test, every class, your reaction, your presence is important. Okay, there is one guideline. There is one guideline that at the end of semester there is an exam. This is normal process. Okay, but it is not mandatory necessarily that this exam is always final. Because now pandemic, anything can happen. Maybe there is no exam, because last time, second semester, there was no exam also. So this time what will happen, no one knows. But you don't please assume that I am saying that there will be no exam. You please don't assume like that. Maybe there is exam, maybe physical exam, maybe through computer, maybe multiple choice, maybe broad question. I don't know exactly. Okay, so decision will be taken later by the authority, by the university, by the UGC. So now objective of the class to know something in a good way. This is the objective, not the exam, not the marks. Okay, so if from very first class you are concerned about your mark sheet, then it is not good symptom. But whatever may be, you have your own right to think, express. This is your interest. Okay, you go on googling. Okay, go on search Google by Suporno Isaac Bari. Okay, can you hear me, Kishloy?
Yes, sir. I am listening you, sir.
So you please just now you can give in your mobile Suporno Suparna Isaac ISSC Isaac ISSSC Isaac Bari BRI Bari. Okay, and you search. You will see that a 8 years boy, he was originated from Bangladesh, but now he is an American citizen. He is a professor of Harvard University. He is a professor of our Mumbai University. He never faced any exam. He never went to any school also. Only 8 years. You just search the Google. Okay, 2019 he came to our Mumbai University, and Mumbai University offered him a professor, honorary professor. You can search and you can find all the VC. Everybody is coming and giving him this kind of felicitation, and he is giving lecture. Okay, so exam is always not important, but it's a conventional way of judging people. So from very beginning, don't always incline towards exam. Because in MSc, I told in the first semester also, everybody will pass. What I see in my experience, everybody, most of you will get more than 70%, 80%. But it is nonsense if you cannot qualify NET, SLAT, if you cannot do PhD, if you cannot do a very good job, if you cannot be resourceful. This is important. So you concentrate on that, not on marks. Marks এমনি পেয়ে যাবে, বুঝতে পারছো ব্যাপারটা? কাজে মার্কস নিয়ে এত তুমি প্রথম দিন থেকে চিন্তা করলে হতো না। আর in my case, maybe I may give internal marks from this exam also. Okay, because there is no specific clear this kind of things. Okay, so Ratan sir expressed his view. I am expressing my views. So you don't go like this. Ratan sir, আপনি তো এরকম বললেন, আরশাদ স্যার এরকম বললো, you don't go like this. Ratan sir কি এরকম বলেছেন, you can interact with him. You don't tell his words to me. Okay?
Okay, sir. Okay, sir.
কে কি বললো আমাকে বলে লাভ নাই, আমারটাও তুমি আরেকজনকে বলে লাভ নাই। যে যেরকম বলেছে সবাই তোমাকে ভালোর জন্যই বলেছে, তুমি সবার কথাই শুনো। না শুনলে তুমি আমাকে বলতে পারো যে স্যার আপনি যে বলেছেন আমি এটা এরকম না, আমি ভাবছি ওইরকম, সেটা তুমি বলতে পারো। ইউ হ্যাভ দ্য রাইট এন্ড আই ওয়েলকাম ইউ, নো প্রবলেম। আই উইল ট্রাই টু জাস্টিফাই মাই প্রেজেন্টেশন, মানে মাই ভিউজ। ওকে, আমি আমার ভিউ তোমাকে জাস্টিফাই করার চেষ্টা করব। না পারলে আমি তোমারটা মেনে নেব, সেটা কোনো অসুবিধা নাই। বিকজ উই আর অ্যানালাইটিক্যাল, উই আর ভেরি ওপেন, উই শুড নট বি স্ট্রিক্ট অন এনি ইস্যু। বুঝতে পারছো ব্যাপারটা? অনেক সময় রাগটা করলাম, ঠিক আছে, এর অর্থই নয় যে উই আর ফিক্সড ইন এন ইস্যু। অলওয়েজ উই আর ওপেন, ইউ ক্যান এক্সপ্রেস ইউর ভিউজ, বাট ইট শুড বি ওপেন। যে কে কি বললো এটা ভেবে লাভ নেই, এতে কি হয়, কনফিউশন অ্যারাইজ করে যায়। বুঝতে পারছো ব্যাপারটা? তো আমার সাজেশন হচ্ছে তোমরা কে কি বললো না বললে, এমন হতে পারে পরীক্ষা হলো না, তাহলে কি তুমি পড়বে না? পড়তে হবে। এবং প্র্যাকটিক্যাল হলো না। আমি আগেও বলেছি যে দেয়ার উইল বি নো জব where you will be assigned to do the characteristics of PN junction. দুনিয়াতে কোথাও জব নেই যেখানে তোমাকে বলবে যে খালি PN জাংশনের ক্যারেক্টারাইজ করো। তাহলে করার উদ্দেশ্য কি? করার উদ্দেশ্য হচ্ছে যে তোমার এরকম একটা ইনস্ট্রুমেন্ট থাকলে হাউ ইউ উইল হ্যান্ডেল, 5 মিনিট শেষ হয়ে আমি আসছি, হাউ ইউ উইল হ্যান্ডেল দ্য situation, how you will handle the experiment, how you will measure, how will you record the data, how will you maintain the instrument, how will you have idea about the science related with the measurement, about the different parts of the instrument. This is the things you have to know. then whenever you will go in real field, if new problems is given to you, you can handle. This is important. তুমি পিএন জেনারেশন করে নিলে খুব এটা কোনো ইস্যু না। কাজেই প্লিজ বি ওপেন, যে কোনো কিছু হতে পারে, কোনো অসুবিধা নাই। বুঝতে পারছো ব্যাপারটা? আর এখানে মার্কস পাওয়ার জন্য চিন্তা করে লাভ নাই, সবাই মার্কস পাবে, এটা নিয়ে কোনো টেনশনের ব্যাপার নাই। এনিওয়ে, সো আর কেউ কিছু বলবে? যেমন আরেকটা কথা বলে দিই, যেমন এই যে আমি ইমেল নিচ্ছি তোমাদের কাছ থেকে, I may consider these emails, I mean your feedback, as an assessment also. যে তুমি যদি ফিডব্যাক না দাও, I will think that কি you didn't go through the homework, you didn't follow my lecture. Okay, so these are all a part of assessment. Okay, আর যদি তুমি আইডিয়ালি খুব ভালো করতো কেউ, তাহলে তো অ্যাসেসমেন্টেরই দরকার নাই, ইউনিভার্সিটি কলেজ কোথাও আসার দরকার নাই, এমনিই হয়ে যেত। সেটা তো হচ্ছে, রবীন্দ্রনাথ হয়েছে, আরো অনেকেই হয়েছে, কিন্তু সেরকম হয় না। বুঝতে পারছো ব্যাপারটা? কাজেই তুমি তোমার যে কোনো কোয়ারি ইউ ক্যান রেজ টু মি, আই এম ভেরি ওপেন, আই উইল ডিসকাস, বাট মাই রিকোয়েস্ট, ডোন্ট ওয়ারি অ্যাবাউট মার্কস, অ্যাবাউট এক্সাম। আই অ্যাসিওর ইউ, অল অফ ইউ উইল গেট ফার্স্ট ক্লাস। কেউ যদি না পায়, আমার রেজাল্ট পড়ায়। বুঝতে পারছো ব্যাপারটা? বিদ্যুৎ?
Yes, sir.
বলছি যে সবাই